All right, hi everybody. I'd like to welcome everybody that's joining. I see we've got a few people that have joined already, and I'd like to welcome everybody to our table talk session today. My name is Chris Van Dyke. I'm a principal SE here at Cloudera, and today what we're going to do is we're going to talk to you about how Cloudera is embracing the scalability of Kubernetes and Azure. Some of you may think of us as a Hadoop company, but with CDP, the Cloudera Data Platform, we've re-architected our platform to take advantage of the cloud. We've separated compute from storage, and now data is stored in the cloud provider's object storage. So think ADLS. All of our customer data is there. And for compute, we're providing data services that take advantage of Kubernetes and containers to give scalable self-service compute experiences. To show you some examples of this, we have a couple of product managers here to give you some demos today and answer some questions. So let's meet our product managers that are here with me today. Michael, go ahead.
Yeah, hey everyone. This is Michael Kors. I'm a product manager in our DATAFLOW group, and I'm going to be walking you through our latest data service on CDP Public Cloud that runs Apache NiFi on AKS clusters.
All right, perfect. And then Sean.
Hey, yeah, hi everyone. Yeah, I'm Sean Amadian, product manager here at Cloudera. I'm responsible for the data engineering service, which is our scalable Spark on Kubernetes, and I'm looking forward to sharing some of our experiences with that.
Awesome, great. Well, now we've got introductions out of the way, and we don't have a lot of time today, so let's go ahead and we're going to jump right in. And Michael, can you show us how Cloudera Dataflow is using AKS to scale out workloads in Azure?
Sure. So first of all, I just want to give you a brief overview of what Cloudera Dataflow in the public cloud really is. So for those of you who know NiFi and who've been using it before, this is the first cloud-native service that you can get from any vendor in the public cloud that runs your Apache NiFi flows in a cloud-native way. That means auto-scaling works out of the box, and you don't have to take care of your deployments once they've been created. For those of you who don't know what Apache NiFi is, it's basically it's a data movement engine that gives you a visual design interface to build your data flows. You can do format transformations, you can do filtering, all the things you need to do to move real-time data. So that's important. It's really built for real-time data movement from one system to another. So we've just recently released this new DataFlow service on CDP Public Cloud that allows any NiFi user to bring their existing NiFi flows, store them in our catalog, and then create deployments in their Azure subscription. And these deployments will then run on Kubernetes, and that's really where we leverage the power of Azure AKS, because all of our deployments run on AKS clusters, and we use the capabilities like the auto-scaling capabilities of AKS to make sure our data flows can handle all the load that we see in these different use cases. So I want to walk you through real quick what that product looks like. So first of all, NiFi itself has this graphical UI where you can build your data flows. And I thought, talking about AKS is great, but why not talk about more Microsoft services in this session? So I built a data flow that we see that's very common with our customers that takes some data from Event Hub and then filters it, merges these individual events together, converts them to Parquet, and writes them to ADLS. So this is just an example of what NiFi can do for you. These processors here are pre-built in NiFi, so you just drag them to this canvas. And if you search for Azure, you'll see all these processes that we support for the Microsoft ecosystem. So I picked Event Hub because it's a very common streaming integration endpoint for us, but there's more like Cosmos DB, data lake storage, blob storage, etc. But you get the idea. Very easy to use these existing processes to build your data flow. Now, this is how I built my data flow visually, right? I can integrate with all these Azure services. Now, I want to run this data flow and move the data from my Event Hub filter it, merge it, and write it to ADLS using our new cloud service. So I'm going to walk you through that real quick, how that works. So what we're seeing right now is CDP Public Cloud. This is our new cloud data platform where we have all these different data services that you can use for different use cases. I'm in our DATAFLOW service right now, which runs these NiFi workflows on Kubernetes. And we're currently looking at the dashboard where we see all these data flows that I've already deployed here. And you see there's one data flow that's writing data to Event Hub. And you can see there's just some constant, it's basically a data generator that's constantly writing data to an Event Hub. And now what we want to do is deploy this flow that we just saw earlier and pick up that data from Event Hub and write it to ADLS. So I'm going to walk you through how that works.
Hey, Michael, can you make your screen just a little bigger, your text, please?
Oh, yeah, sure.
Thank you. Perfect.
That's now really big for me, so I hope it's big enough for so in our catalog, we have stored this data flow that I've shown you earlier that we developed in NiFi, which is this Event Hub filter to ADLS flow. So I'm going to start deploying this now from the catalog, and just going to hit that deploy button and pick my Azure environment where I'm running. So this would be your Azure subscription where you want to run this data flow. And now I'm going to be walking through the deployment wizard that helps me to provide all the data that we need, all the configuration properties that we need to really spin up this data flow. So I'm just going to give this a name, Event Hub to ADLS. I'm going to deploy the latest NiFi version here. And now I can specify parameters that I require for my flow. So you can see here's where I specify my ADLS directory, my file system name, the storage account, and down here we have the Event Hub configuration. So I'm going to specify a password and also the primary key real quick. So these are some secrets that I need to provide to connect to the systems. And then I'm going to move on to the final step, which shows you again, this is how easy it is to configure the scaling. I can say I want a small deployment here that scales up to maximum 3 nodes. So again, scaling is powered by AKS. And in the final step, I can define KPIs for my data flow that allows me to, for example, stay on top of how much data we are reading in total from Event Hub. And I can say I want an alert whenever that's less than 150 kilobytes for 30 seconds. Common thing also to be interested in is the latency. How long does it take me to write an event to ADLS? So I can pick the average lineage duration to stay on top of this and also add this KPI to my flow. Now, done everything I needed to deploy this data flow. And once I hit that deploy button, that's really when this data flow service now does all its magic and it starts spinning up a completely new NiFi deployment on that AKS cluster. Takes a couple of minutes, but then we'll start seeing data flow through here. And because that'll now take a few minutes, let's just quickly have a look at this deployment here. So this is the one that creates data and writes to Event Hub. So if I want to go and see the actual data flow that's deployed here, I can just go to that manage deployment view. And then in here, I can go to the actual NiFi data flow interface where I see what is actually being executed here. So this looks very familiar to what you've seen in the very beginning. All right, let's see if that loads. Yeah, there we go. So this is our actual data flow that we've deployed. So you see that each of these deployments is running an actual NiFi data flow that then automatically scales up, scales back down as needed. And with these pre-configured processors in NiFi, super easy to integrate with all these Azure services for your real-time data movement needs. So that, in a nutshell, Chris, is Cloudera Data Flow for the public cloud on Azure.
Very cool. One of the things I like about what you just showed is it really shows how we're embracing hybrid, and we're able to take like an on-prem NiFi flow and bring that to the cloud, and then use the elasticity of the cloud to kind of scale that out. So very cool. Okay, that was awesome. All right, so Sean, your turn. Cloudera Data Engineering is making it easier to move data engineering jobs into production, and providing Spark as a service. Can you kind of show us a little bit of that and what that looks like? Oh, hey, Sean, you're muted. Sean?
Mute myself.
There you
Okay.
go.
Okay, all right.
Awesome.
All right, okay. So quickly, not trying to put too many slides up, but I sometimes like to give some context for why, you know, what we're seeing as we're working with lots of enterprise customers on-premise, in the cloud, sort of what are the changes that we're seeing? And I like to focus a lot on the people, processes, and products. And when we work with a lot of our customers, you know, we're seeing a shift as the data teams are evolving. So we're seeing, obviously, we have the platform teams. We start seeing a central data team that's really focused on the main core data engineering, but we're seeing a big shift to, and I'm pretty sure many of you have seen this shift happen, where we have these data teams within the organization and different parts of the organization that are really focused on their domain knowledge. And so with that, we also see the process that's changing and evolving with it. So again, a lot of the central data teams tend to be focused more on the extraction and the loading of the data, making sure it's secure and available, operationally available. But then the data teams that are in other parts of the organization are doing a lot of the heavy lifting on the transformation side. I sometimes put a little D in front of the T to say these are domain-specific transforms. And that's kind of a really important shift that we're seeing, that we do see these.
Oh, we lost your audio. Sorry about that.
Hey, Sean, we lost your audio there.
Oh, can you hear me?
There you go. Hear you now.
Oh, okay. Okay. So anyways, we have the EL and then the T aspect. And so with that, so we talked a little bit about the people, the processes. The other aspect is obviously the tooling. And so with that, the central data teams, as I mentioned, a lot of their focus is on the scaling aspects, the automation, making sure that workloads are isolated. Besides obviously bringing and landing the data within the data lake, they're going to try to work as the core data engineers to really enable the external data teams, you know, the organizational data teams. And with the organizational data teams, they want to take that data and they want to do the transformations based on their domain expertise. And, you know, sometimes there are other names that you might hear of them. They might be called analytics engineers. But a lot of their focus is going to be, you know, self-service capabilities, operational best practices. So we want to take some of the best practices that we see from a DevOps, from a data engineering, software engineering aspects, and make sure that the organizational data teams are following those capabilities. So with that, let me just kind of jump into just like one more slide. So this is actually how we ended up setting, you know, architecting on top of Azure and AKS. So we obviously leverage AKS as kind of the core foundation. And on top of that, we've actually built what we call Apache Unicorn, which is a dedicated resource scheduler for Kubernetes. This is quite different. It gives us a lot more flexibility in terms of queuing, application queuing, different policies for how we allocate pods. And then, of course, we layer on top of that Spark and Apache Airflow, a combination that we find to be really critical to the data engineering workloads. And then we use that. We have a management API, which then exposes a lot of different capabilities for automation. And so all of these eventually are serving the different needs of the teams and the processes that we're seeing evolve. So within our CDE data service, similar to what Michael showed earlier, we have a notion of a CDE service. Within that, we have different Kubernetes clusters that are being created. As you can see, we're multi-cloud. So we not only just run on AWS, we also have Azure. And so here you'll see different data lakes and their associated Kubernetes. And one of the key aspects, if I go into the details, is I'm able to scale out and determine the auto-scaling capabilities of my AKS cluster. And you can see that we've set this to be from 1 node to 20 nodes. We also have our resource scheduler that I mentioned, which is Unicorn. So you can see the capabilities that it lets us do at a very core level, allows us to do application scheduling, prioritization, gang first in, first out. So all these things that are really important within the Kubernetes to give us the elasticity and orchestration of the resources. Now, once you have that set up, it's really easy to onboard new tenants. So this notion of creating isolated workloads. So I can come in and let's say I have a new marketing workload. I can come specify that as a new tenant. I can set some quota limits on it. And then with a few clicks, start provisioning an isolated, within this Kubernetes cluster, an isolated compute capacity within which I can start where we run not only Spark, but we also run Airflow. So here we have access to Airflow that's provisioned. So you'll see that we have a full-fledged Apache Airflow instance that's fully integrated and secure. And then also we have our other capabilities like our API that you can access through a CLI. And at the end of the day, we actually want to be able to go and deploy workloads fairly quickly. And so we have a UI that allows you to jump in and look at a list of jobs that you have been creating. One of the nice things is we have a simple wizard for you to deploy Spark workloads on Kubernetes. So here I can come in and define, let's say this is a Spark demo job. I can upload Java, Scala, as well as PySpark jobs. So here I have a simple PySpark job that I can deploy. We automatically can let you choose the Python version that you want. We also give you a lot of other levers to configure your Spark workload to run. So here you can add dependencies. We automatically have what we call dynamic allocation, which allows your Spark applications to scale out based on how much resources it needs. And I can also tweak kind of the number of cores and from an optimization standpoint, how much the drivers and memory, driver memory and executor memory that I want. And then we can also schedule the job to run using a very simple scheduler, which behind the scenes, we end up using Apache Airflow. So once I have my job ready, I have all kinds of management capabilities. I can schedule it, configure it, I can execute a run. What will end up happening is we create all the necessary artifacts for this job. We store them into what we call a resource. So these could be various dependencies, file-based dependencies. So here you'll see the job, the PySpark, the Python job that I just uploaded. And then we load all these and mount them to all the executors that are being brought up on AKS. So all the pods for the executors and drivers get the necessary resources in terms of the actual code that needs to be run and the dependencies. And we bring all the necessary kind of monitoring capabilities, again, as a self-service aspect to the end user. So I can see the trends, I can see the configuration that I used. We right away start streaming all the logs across the drivers and executors to the end user so they can get a quick understanding of what their jobs are doing. We also link in the Spark history server as my job makes more progress. And at the end, you'll be able to do some of the analysis that you'll be able to look at in your jobs are like this. So where we actually bring in some additional metrics along CPU and memory utilization to be able to understand where the bottlenecks are within your job. So we give visual profiling capabilities to the end users, to the analytics engineers to be able to understand what their jobs are doing. And then last but not least, just to kind of round it out. So at the end, I have Spark jobs that I've deployed, and then at the same time, we want to be able to create pipelines. So, these could be much more complex pipelines. So we have a full-fledged UI now that allows you to start defining these pipelines, these batch-oriented pipelines. And so in here, I can, for example, drag and drop and say, hey, I have this existing pipeline. I can bring in this new job that I started creating, that I created. So my Spark demo job, I can start linking in and adding it and appending it to my existing pipeline, and then simply save this and start executing this as an Apache Airflow DAG. And you'll see that behind the scenes, we have Apache Airflow. It'll get registered. I can see that instead of having to write all the necessary code, it automatically creates the Airflow DAG for us, and I can start executing. So all of this in a very scalable fashion, obviously built all on top of Kubernetes and leveraging the power of Azure. So with that, back to you, Chris.
Okay, very cool. Well, I guess, so with that, we've shown a lot of the Cloudera Data Platform. How does, for either one of you, how are we then taking that Cloudera Data Platform, and how are we spinning these services up in AKS? Does the end user, are they having to do anything in AKS to get ready for this?
Yeah, you want to take it?
Either one of y'all?
Oh. Yeah, so
hey, Mike, hold on, Michael, you're muted. Go ahead, Sean.
Yeah, so one of the key aspects for us is obviously the CDP platform. Once you have CDP set up within your environment, within your cloud Azure environment, then it's pretty straightforward to actually spin up what I saw. For example, in the data engineering case, you saw the data services that I mentioned, which are the Kubernetes clusters. The AKS clusters, they're pretty straightforward. You just have to specify a few parameters and then you're good to go.
Right. I think that is a neat part of the way we've tackled this, is we've really built our own, we've built a system internal to our platform to be able to go and provision these services out in AKS. Very cool.
I think another important thing here is that the workloads, right? While we automate everything, we automate the AKS cluster creation. We also automate the upgrades later for you. That AKS cluster is still running in your subscription, so you're still in control of the data. It's not running in Cloudera subscription. We're just orchestrating and automating everything.
Right, and we're taking advantage of behind the scenes. We're taking advantage of the ability for AKS to spin up compute and then spin down compute when there's nothing happening. So that really cuts down on the customer's consumption in Azure. So they just use what they need, and then it goes away when they don't need it. So very good. So how about for either one of you? How about between the two services, what are we doing to have interactions between the two services, between CDF and Cloudera Data Engineering?
So I think when Sean showed the slide where you saw the core data team that is concerned about the extract and loading, that can be the role of Cloudera Dataflow, and it is for many customers, because we have that rich ecosystem of connectors to basically any system you want to collect the data from. And what we see a lot of customers do is they do some initial, maybe small size transformation, or just reformatting the data, and they land it in ADLS. And I think that's where then really, Sean, right, these specialized data teams would take over. So ADLS is typically a good handover between these services that we see.
Very good. Very good. Well, hey, Sean, I know when I introduced you, I talked about Spark as a service. What have we, with Cloudera Data Engineering, what have we done to kind of transform the way a user interacts with Spark? I know, are we still using Spark submits?
Well, yeah, we try to, one of the key aspects is, we know all the issues or challenges that to scale. So there's one thing, Spark is really great. It's, it's very flexible, it's code centric, but at the end of the day, what's really challenging is to take your Spark and to deploy it at scale in production. there's a lot of challenges that come with that. They start with, either tuning, monitoring what's happening, and getting that visibility. And so for us, one thing that we really wanted to change was the operational aspects of deploying Spark. So in the demo, it was kind of a lot of things, but we showed how you use a simple wizard to deploy that job. But behind the scenes, what's really happening is we have what's called a job management API. And so the job management API embeds in it like the best practices we've seen with operationalizing Spark jobs. So it forces you to use a centralized mechanism to deal with your resources, like the job code, let's say libraries. There's a very centralized ways for you to check the status of your job, to expose the logs of the jobs. We also do profiling of the jobs in a very centralized way through our management API. So we felt that really Spark Submit was just kind of a very baseline, and what we really added was a completely new management API that really follows the life cycle of your jobs.
Right. No, very good. Okay, we've got actually anybody out there. We have a few minutes left. Please use the Q&A to publish your questions, and we'll answer them. I've got a couple questions. The first one is from Nanda, and Nanda's asking, we have a requirement where we have a cluster with, they're asking about the number of compute nodes that they have within AKS, and they've hit their limit, and how they can work with that. And I can actually answer that one. One of the nice things, you have those limits within your Azure subscription of how many nodes you can have. If you hit that limit, put in a help desk ticket, and Microsoft and the Azure support team, they'll increase that limit so you can have more nodes. For the second question from Prasanna, what is your trigger for auto scale AKS nodes if capacity is at max on the existing nodes? Do you have an event-based trigger? And also, do you have any metrics on how long it takes to scale up new pods to be healthy to accept traffic? Michael, Sean, do you want to, either way, you want to take that one? Because it can be different by service.
For us on the DataFlow side, we're really looking at the CPU utilization of the individual pods. That is a really good proxy metric for general NiFi utilization. And when it reaches a certain percentage for a certain period of time, then our operator recognizes that and the autoscaler recognizes it and tries to spin up a new pod. And then because of that, if that new pod doesn't fit on the existing number of AKS nodes that we currently have provisioned, this will in turn trigger an AKS auto-scaling event. So you have these two layers of scaling. First, like on the pod layer, and if we run out of AKS nodes, then like the lower layer of AKS nodes would also scale. New pod typically takes a couple of minutes to be up and process data.
Okay. Okay, Sean, did you have any kind of another take on some of that?
No, that's kind of the key aspect. Obviously, with Spark, we monitor both the memory and CPU, and we look at how many executors you can allocate based on your capacity.
Right.
And so you're able to do that. And obviously, I mentioned Apache Unicorn, which is a resource scheduler that we use, and so that allows us to really scale up fairly quickly as demand comes in from new jobs. So I'll kind of put it in the chat in case you guys haven't seen it, but put a link. We've done a blog post about its performance, so it's a key aspect of it.
All right, and yeah, we did a webinar a few weeks ago where we showed the interaction between DataFlow and the data engineering experiences. And with one of the neat things about it is we did we had some logic in the DataFlow that would change the number of executors and everything when we submitted the jobs using the jobs API. So you do have a little bit of functionality there you can work with. All right, well, very good. Well, I'm being told by our directors that we're hitting our time limit. I'd like to thank everybody for coming and watching today. Thanks, Sean, thanks for you and Michael coming on and doing the demonstrations. And thank you, Microsoft, for having us. I hope everybody enjoyed this and enjoy the rest of your Ignite conference. Thanks a lot.